Lenses are devices that form images by refracting light. Now, refraction is the phenomenon of waves changing direction when transmitting from one medium into another, such as light waves transmitting from air to glass. By refracting the light from an object in a certain way, we can form an image that appears to be different to the object. For example, a magnifying glass uses a lens to create an image of an object that is much larger than the object. This lets us view small objects in greater detail. A microscope uses a lens for a similar purpose. Binoculars use lenses to create images that appear to be closer than the objects they are of. This is useful for viewing faraway objects, which we can also do with telescopes. Other applications of lenses are cameras and our eyes, as we need to produce images for our brain or film to interpret. Glasses can use lenses to adjust the refraction of light to help make images easier to form. In your exam, any questions on the topic of lenses will focus on the theory more than the practical applications, but it's still helpful to understand what kinds of devices will be using lenses. Now let's look at the two main types of lenses you need to know about. A convex lens will cause light rays to converge. Here's an example of the cross-section of a convex lens. It's a specially shaped piece of glass, which is symmetrical down the middle. Each edge has the curvature of a circle, meaning they would line up perfectly with a circle of the right radius. But how does this cause light rays to converge? Well, to answer this, let's first understand what happens to a thin light ray that approaches the lens like so. Notice that this ray is perpendicular to the line of symmetry that we can imagine in the lens. When the light reaches the lens, it will be transmitting from air to glass at an angle, meaning there will be refraction. In this case, the light will be slowing down and changing its direction accordingly. We can draw in the normal to the lens at this point, which is the line perpendicular to the boundary. Since the light is slowing down, it will bend towards the normal, and then continue on in this path through the lens. Then, at the next boundary, it will refract again as it transmits from the glass back into the air. We can then draw another normal at this boundary, but this time, as the light speeds up, it will bend away from this normal, and it will then continue on this path. Now let's suppose we had another light ray, which was travelling parallel to the first. Again, it will refract and bend towards the normal when it transmits into the glass like so, and then refract again and bend away from the normal as it leaves the glass. As we can see, these two rays have now converged and met at this point. In fact, the lens is curved in such a way that if we take any rays parallel to these two, they will also be refracted and pass through this point. This is what forms an image. So that's how a convex lens works. But what's the other main type of lens? A concave lens will cause light rays to diverge. Here's a cross-section of a concave lens. Again, this will typically be made with glass. Like a convex lens, it's symmetrical down the middle, and the curves would line up with a circle. But this time, the lens curves inwards instead of outwards. If you ever get the names of these two lenses mixed up, remember that a concave lens forms this cave-like shape with its curvature. Let's also look at how light travelling perpendicular to the lens's line of symmetry refracts. Again, we have the light refracting as it enters the lens. We can draw in the normal at this point, which we know the light will bend towards, and then travel through the lens like so. Then it will refract again when leaving the lens. We can then draw in another normal, which the light will bend away from. The light will then continue out of the lens like so. Now what about this parallel ray? Again, it will refract and bend towards the normal when it enters the lens, and then bend away from the normal as it leaves the lens. But notice this has sent the light away from the first, so the rays aren't going to meet. In fact, all the rays parallel to these two will move away from each other and never meet after passing through the lens. An image is instead formed by tracing these new paths back to a point on the initial side of the lens. But we'll look at that in more detail elsewhere. For now, make sure you can remember the main difference between these two types of lens. Convex lenses make rays converge, and concave lenses make them diverge.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!